Welcome back to my channel, everyone. Street Tips here, and we've got our gold refining waste temporary waste containers here. And what I'm going to do is I've got my vacuum rig set up here. I've got a 4-liter filter flask down here, and then I've got this little rig set up. Normally I connect the vacuum line to this hose right here, but I've got it plugged up with a golf tee. I don't know if this is going to work or not. I've got a rubber gasket here around the neck of the filter flask, so we're going to try to configure this. Oh yeah, we're pulling a nice vacuum over there. What we're going to do now is I'll siphon all the liquid out of this container. Here we go. Now that we have the waste removed from our temporary waste container up here, I need to add this to my stock pot. My stock pot is full of copper. In here, any traces of precious metals that are in this solution will cement out as a fine black powder and fall to the bottom of this bucket, and then I can recover those metals. This one is one of two. It's been covered and allowed to stand and settle for about 4 days. In order for me to get this liquid into this stock pot on those pieces of copper, I must first siphon this solution that's going to be full of copper, no precious metals, just copper, down into my waste treatment bucket down here that's full of iron. In here, any copper that's in solution cements out on those pieces of angle iron that I have in there as metallic iron, or as metallic copper rather, on those pieces of iron. Those pieces of iron in there will cement out the copper, harmless metallic copper like this, but it's highly contaminated with other junk. There's probably 10 pounds of copper in here, maybe a little more. You know, copper at $4 a pound, $40 worth of copper in there. That's nothing compared to what we'll be working with up here. There's probably going to be, between these two containers, maybe 10 or 12 grams or so of pure gold. That's worth going after. The copper down here in this container is just not worth the effort to try to recover. Copper is a very useful metal in refining precious metals, but once we've used it to get those metals out of solution, it's pretty much just waste. I'm going to siphon this copper solution out of my stock pot down into my waste treatment bucket. Here's a look down in the stock pot. There's going to be some black sediment down there, that black mud, and that will contain traces of precious metals. And about a year from this date right here, we'll get in here and do a refining on it. But for right now, what we're going to do is take this waste that we just gathered into our waste treatment bucket, and we're going to put this outside and bubble some air through it so that the copper will come out of solution onto those pieces of iron. All right, here's our waste treatment bucket that we just filled with our waste. What I do is I have a bubbler here, And I bubble air through this to create some movement. This is my stock pot over here, stock pot number 2. Now we'll add this solution that we just siphoned off from our temporary waste container. I'm going to add this to our stock pot that's full of copper. Any traces of precious metals in this solution that I'm pouring off into the stock pot will cement out on that copper as a fine black powder and fall to the bottom of the stock pot, and then we can recover it. This is another bucket of waste that I've accumulated, and I just stuck it down in a bucket down here, get it out of the way. But what we're going to do is we're going to pour some of this waste. You can see the fine gold powder down on the bottom of this bucket, but we're going to pour this solution now into our into this stock pot and just slowly get rid of this over time until we have it all added to the stock pot. Now what I'll do is I'll cover this stock pot up. We'll take this out on the pad and bubble some air through it. Bring the one in there that's been bubbling for the last 4 days. We'll bring that in and cover it up and let it settle. Take this one in, let it settle. And what we'll do then is take this one and put it on the bubbler and let it react. The flask is empty. I've got a very fine tip on here now. So what we're going to do is go down in here and get the rest of the liquid off of here without disturbing the gold that's settled on the bottom of our container. Now let's get in here and get the solution off of this settled out gold in this jug. Here's the liquid that I drew off. Got just a little bit of gold in it. That's quite all right. I'll add this to the stock pot. But what we're going to do now is we're going to go ahead and start dissolving the metals in these waste containers. I'm adding hydrochloric acid. Again, hydrochloric acid is the same thing as muriatic acid. Muriatic acid is hydrochloric acid. Two names for the same product. And we're just going to add some hydrochloric acid to both of these containers. This container has some gold that's adhering to the inside of it. Try to rinse it down. I've got some hydrochloric acid in a squirt bottle here. And get that down into the bottom of the container here. Some hydrochloric acid. Keep it in a squirt container. Now I'm going to put the container up here on the heat. I don't know about this jug, whether it's rated for heat or not, so I'm just going to have to start heating this tray back here real low. Start heating this one up. Alright, let's see. This This is heating up just a little bit. I don't need much heat on this one because I don't know if this is going to take any heat. So I just want to keep it warm to aid the reaction. I'm adding some shots of nitric acid. And this should put the gold in solution for us. Might have to use a little extra on this big container because I can't heat it very strongly. I'm going to start to heat these up a little bit. This one I can heat no problem. This one over here I'm going to have to watch it. Just let this stuff slowly dissolve. I've turned the heat off on this one over here. I'm going to kill the heat on this. I think we've got everything in here to dissolve. And this one's going pretty good. For being cold, it's dissolving nicely. Give it a stir here and let it continue. These solutions have been allowed to cool now. I'm going to add them to this beaker. We've got our solution in this beaker now. Reach down in here and get a little bit on a piece of filter paper. And we're going to test this with stannous just to make sure that we've got gold in solution. We know we do, but it doesn't hurt to test it. Let's cover this up. Put it up on the heat. And we're going to evaporate this down to remove any excess nitric acid that we might have in there. I've got it evaporated down to almost nothing. I'm going to start rehydrating with some hydrochloric acid. This is to drive off any excess nitric that we may have had present, which is highly likely because we used way more nitric than we needed when we dissolved it in our containers. I'm going to add just a little bit more hydrochloric acid, about 40 milliliters. I didn't see any fume production in there. I think it's fairly safe to conclude that we've got all the excess nitric expelled from the solution. Pull it down, let it cool off. Cool it down with some ice. I've got a filter set up. Number 2 slow or medium flow filter. Now we're gonna filter our solution. Let's add some distilled water to this beaker. About 300 milliliters. Now what we'll do is I've got some ferrous sulfate here. Ferrous sulfate will precipitate the gold, all the gold, and nothing but the gold. And I'm thinking we may have some platinum group metals in here. So let's dissolve a little bit of ferrous sulfate and use that to precipitate our gold. I'm going to put a stir bar in here. I'm going to add a little heat and dissolve our ferrous sulfate in distilled water. We did have some junk in our gold, and we've got it all captured in this filter now. Solution out of here. I'm going to add the solution to our beaker down here. Looks pretty good. It's got some condensate on here. From the solution itself is nice and clear. Got a funnel set up with a filter on it here. Before we go any further, let's add some hydrochloric acid to this ferrous sulfate. See if we can get it to green up for us. Let's take our ferrous sulfate. Let's get that stir bar out of there. Now what we'll do is add our ferrous sulfate to our gold down here. Got a filter set up. I'm going to filter the ferrous sulfate. I'm going to add it right on into our gold solution. Should precipitate out quickly. This won't be as dramatic as adding SMB, but it should come out of solution rather nicely. Again, the ferrous sulfate will just precipitate the gold, only the gold. And I thought I seen a little bit of a platinum indication on our stannous test. So we don't want that, the platinum, coming down with our gold. Alright, I forgot to get a stannous test. Reach down in here and get some of our solution on that filter paper so we can get us a stannous test. It's important to do it. I know there's gold in there, but it's important to get a stannous test before we do the precipitation. There you can see we've got gold in solution. I don't need to filter this. This is a reagent grade ferrous sulfate. So I think what we're going to do is just add it right on in. It's crystal clear. There's nothing in our filter. Just going to pour this in as we gently stir it a little bit. And this should cause all of our gold to drop out of solution. I think we've got everything precipitated now. Do a quick stannous test here. There you can see all the gold has precipitated. We're getting just a little bit of an indication for maybe some platinum in solution. Maybe palladium. Really like this reagent grade ferrous sulfate. I'll hang on to this and use it in a future precipitation. Well, it's only been about 5 minutes since we did the precipitation, and this thing has settled out nicely. Pour off this waste now. Let me see if I can. Where's my squirt bottle? I rinse it a couple times with some distilled water. Now what we'll do is hit it with some hydrochloric acid. See how that color comes back out? Hydrochloric acid is better at rinsing the gold free of that iron than just plain distilled water would do. See how the water's colorless? And then when we hit it with the hydrochloric acid, you'll see that we still get a little bit of color coming out of there from the ferrous sulfate. Not much, but it's detectable visually. I'm adding a little hydrochloric acid, probably about maybe 50 or 75 milliliters. And we'll cover this up, set it back up on the heat over here. Let's add a few drops of sulfuric acid, just in case there's any lead present. Not much, half a milliliter or so. Now we'll add some nitric acid. And this should dissolve our gold. This will make aqua regia in there. About 3 milliliters of nitric acid. Actually, I'm just going to go with half of that. Hang on to this. Well, that was easy. It only took a few minutes, maybe about 10 minutes to get this to dissolve completely. Let's pull it down here and let it cool off now. Let's add an ice cube. Cool this thing down. Probably totally unnecessary, but let's go ahead and run it through a filter. The solution is absolutely crystal clear. You can read a newspaper through it. Let's go ahead and pull it through the filter anyway. Okay, there still is a little bit of junk in here, it looks like. They got trapped in our filter. Go. See if we can do this all in one take. Let's precipitate out the gold with some stump out. It's actually sodium metabisulfite. I ran out of stump out, so this one spoon ought to do it here. Let's go. One spoon. There it goes. I think we've got everything to go into solution, or come out of solution rather. Let this settle now. Only took about 20-25 minutes for that gold to settle completely. And if you look over here, this is our new waste container. We're already starting a new collection of bits of gold in there. So what we'll do now is we're going to pour off the waste solution out of here and rinse our gold a couple times with some hydrochloric acid and some distilled water. Here's what the gold looks like down in our beaker. Here we go. Hydrochloric acid going in. About 75 milliliters. And now we'll stick this up on the heat. Give this a boil. Let's drop in a stir bar. This is a new one. And turn on the stirring. I've got some 29% hydrogen peroxide. What I'll do is measure out about 100 100 milliliters. Here we go. We're gonna add some of our 29% hydrogen peroxide and get this gold to dissolve a third time. Let's go ahead and add another little shot of hydrogen peroxide. This is about 3 milliliters. I just drop it in a little bit at a time, and you'll notice that boom, all of a sudden there it goes. Creates a lot of heat and a lot of foam when the reaction starts. This is a very, very clean method of dissolving our gold. None of the fumes associated with nitric acid, aqua regia, and there's no nitric acid to have to deal with to denox before we do the precipitation, because we're not using nitric, we're using hydrogen peroxide. I'm adding a little bit more hydrochloric acid just to make sure we've got plenty in there to complete this reaction. Almost got it completely dissolved. Been at this about a half an hour now, and you can see there's just a tiny bit of gold left down in there. So, and I'm almost to the bottom of our hydrogen peroxide here. Put this last bit in. And this is something peculiar about using hydrogen peroxide. That last little bit of gold usually stubbornly remains undissolved in the solution. So once I get this last bit of hydrogen peroxide in here, then we'll pull it down off of the heat and let it cool off. There, that's it. That's it for the hydrogen peroxide. Let's kill the heat, and we're going to pull this down off the heating pad here. Let this cool off a little bit. Let me get that stir bar out of there. This is just a magnet. Gonna rinse it off with some distilled water and then get it out of there. Here you can see there's just a little bit of undissolved gold left down in there. I could continue and get every little trace of it to go into solution. Been at it for 45 minutes, so it'd probably take another 20 25 minutes just to get that little bit of gold to dissolve. So I'll just use that. I'll put it in my waste container and contribute to my next waste container refining video. I'm adding an ice cube to cool it down. Got a filter flask set up here. Now what we'll do is pour our solution through the filter flask, through the filter. Clean beaker. There's our solution. Crystal clear, looks gorgeous. Now let's pull down our SMB. What we'll do is precipitate out the gold with some SMB. 1 spoon should do it. 1 spoon of SMB. I keep forgetting to get a stannous test. It's important to do it. I know there's gold in there, but it's important to get the stannous test. Alright, a single spoon of SMB in there should be enough to precipitate all the gold. There's only going to be 8 or 10 grams of gold in there, maybe. Stannous test. It's obvious that there's no gold in solution. We'll do the test anyway just to verify it. There you have it. Negative stannous means all the gold has precipitated. Let's start out with this little bit of gold. It's down in this beaker. Like I said, it's just very little amount, less than 1/10 of a gram. So it just wasn't worth spending the extra time to try to dissolve it. So we'll just add that now to our waste container. And we'll pluck that out of there the next time we do a waste container refining. Now what I'll do is pour this waste solution off into our waste container, and then we'll rinse multiple times with hydrochloric acid. How pretty that gold is, man. Once I get this off of here, we'll rinse multiple times with distilled water and hydrochloric acid. Alright, here's how our gold looks. Very nice. Now let's add some hydrochloric acid. We'll set this up on the heat and give this a boil with some hydrochloric acid. Alright, we got this boiled off in some hydrochloric acid. This always seems to help clean up the gold in the beaker. It's got a nice bright color to it now. This hydrochloric acid I just rinsed with cold hydrochloric acid. And now what we'll do is rinse it a couple times with some water. Oh yeah, look at the color of that. Nice caramel brown color. Nice and fluffy. I got some high purity gold here. That's distilled water. Alright, here's how our gold looks, man. That is just beautiful. Here's our Sunday go-to-meeting melt dish. Let's get the gold down in here now. Let's take our fine gold powder. Bring it over to the melt table. I'm going to melt this up a little ingot here. I don't like that shape. It's got a sharp edge on one side. So we're going to throw it back in the melt dish and try to remelt it into a nice little ingot here in this smaller cavity on our mold. That's better. It looks a little better. Alright, I think I can live with that one. A little better. I've poured better looking bars, but this one will work. Alright, here's our little bar. It's got a mirror finish. High purity gold, no traces of contamination. Let's put it up here on a scale and see what we got for weight. 8.5 grams. 8.6 of high purity gold. Alright, let me see if I can put my stamp on here very carefully. What do we get? We got retips. That's okay. We'll know what it means. Put a little stamp on it here. There we go. Look at the shine on that thing. Beautiful. Well, we can't always get exactly what we want. Would have been nice if it said retips. It says retips. Didn't get the S. The bar is too small to get the whole thing on there, I guess. And we got 3 9s on it. This is out of our waste container. 8.6 grams of high purity gold. We'll offer this for sale on my eBay site. This will conclude the video. Thank you for watching.